Hi everyone, my name is Catarina Madeira and I'm a program director at MIT Startup Exchange. I'm really delighted to be with you today to tell you about the program and how you can get involved as well. Startup Exchange was created about 8 years ago to foster collaborations between MIT connected startups and ILP corporate members. These startups are coming from different MIT labs, departments. We roughly support a network of well over 1,000 MIT connected startups and 250 corporate members that are located across the globe and working across industries as well. We facilitate several hundreds of highly vetted introductions throughout the year, and these are some of the success cases we had to date, which include pilots, license agreements, customer agreements, and other kinds of partnerships as well. Startup Exchange is sector agnostic and geography agnostic as well. The companies might be founded or co-founded by MIT alumni, staff, faculty. They might be based on technology licensed out of the institute and be supported as well by other groups affiliated to the institute, such as Build.nano, led by MIT Nano, and The Engine, just to name a couple. These are some of the ways corporate members can get involved in the program and meet entrepreneurs. Our office organizes many events throughout the year. Webinars and conferences that are still happening on a hybrid mode. Members can meet the startups on a one-on-one and have access to STEX25, a group of some of the most industry-ready companies to which we provide a more customized support, including at the promotional level. And a very interesting way for corporates to engage with us is by sending us opportunities. These are mostly challenges that we then share with all the companies. They can apply to it, and then the corporate selects the ones that seem to be the best fit to help them solve those particular challenges. And here we have 3 of our upcoming events. We are particularly excited with the MIT Alto Symposium because it's the first time we're going to Helsinki, or that we're hosting an event in Helsinki. So if you're around on April 26th, please do join us. And we're very happy as well to bring back the in-person Startup Ecosystem Conference on May 4, which will be followed by another conference focused on AI and computing on May 5. So, but you'll find the detailed agendas on both websites, ILP and Startup Exchange. And now, without further ado, it is time to hear from the 5 startups pitching today. Thank you very much to Scott, Ross, Hunter, Richard, and Nora for being with us. And I'd like to call back on stage Steve Weikal from the Center of Real Estate to introduce the entrepreneurs.
Oh, good, we're live. Okay, so anyway, these are the lightning talks. It is going to move at a lightning pace so that we can stay on track. And as you know, I love being around startups and meeting all the founders, and we've got 5 great ones here today who are going to tell you a little bit about what they're doing. Then you get a chance to see those 5 and others in the lunchroom later while we're getting by tea. So we'll start with Sweetwater. Scott Tudman is the CTO. He's here today. Sweetwater has a patented technology that extracts cellulose, hemicellulose, and lignin from several types of biomass more cost effectively than any other biorefinery technology on the market today. He's going to explain what I just said. I'll turn it over to you. Did I do okay?
That was really good. So, hello everyone. My name is Scott Tudman, Chief Technology Officer at Sweetwater Energy. I'd like to give you a brief introduction to our sunburst pretreatment technology and show you how it can really serve as the driving force behind a true biorefinery. So I'll just start out with a little known. I mean, there's a abundance of really good science out there. A lot done here, right here at MIT, actually. It shows that biomass fractions can be used to create or enhance materials that we use every day. And by biomass fractions, I'm referring to nanofibrillated and microcrystalline cellulose, as well as lignin and cellulosic sugars, the main components of a biomass material. One of the issues with developing that and really pushing it forward into commercialization is that the current fractionation technologies aren't efficient enough to extract those components in a cost-effective manner. It just costs too much to really get them into widespread use in commodity markets. A lot of times you get fairly low yields, so you might be lucky to get 50% of that starting biomass converted into some of these products. And what's really needed is a scalable pretreatment system that's kind of fast and efficient and gets high yields. So what you want is that whole barrel approach to biorefining that you see in the petroleum industry. It's mandatory in the petroleum industry. It has to be applied to biorefining to make it economically viable. So we've been spending a good amount of time developing that solution, and the solution is our Sunburst pretreatment system. And it's an elegant solution. So real quick, it's based on twin screw extrusion. For those of you that aren't familiar, twin screw extruders are industrial pieces of equipment used across many industries. We simply modify it to suit our needs. So if you can picture biomass going in, and we can process a wide variety of different biomass materials, but you can picture wood chips coming into the feed zone of that extruder. We look to do three things as it passes through that extruder. Fibrillate, so mechanically downsize that biomass. We impart dilute acid hydrolysis, a chemical reaction, and then as it comes out, there's a steam explosion. So in 20 seconds or less, you go from wood chips to a very well deconstructed, delicious looking, chocolate pudding looking material, right? What's coming up to lunch, right? So it is delicious looking. And that allows us to very quickly and efficiently further fractionate that into our main product groups. And that, as mentioned, there's a microcrystalline and nanofibrillated cellulose. They have some unique qualities compared to what other people are making out there. Really clean, non-sulfonated lignin. So it's differentiated from lignins that are typically derived from the pulp and paper process. And cellulosic sugars. So they're relatively clean and highly fermentable. So you plug that Sunburst system at the front end of that biorefinery, and we can make various flavors of those three main product groups, right? And the key here is that utilizing that effective pretreatment, we can convert 90% or more of that starting biomass into these intermediate products, right? So it's really getting to that whole barrel approach. And if we use our nanofibrillated cellulose as an example, first of all, when we produce it, we have a very low energy pathway to produce that material. So it's a very efficient low energy pathway, so we're already at an advantage to most people out there in the industry. But then the sale of the lignin and the sugar products effectively subsidize the production of that material. So we can produce and sell our NFC at a fraction of the cost of what others can. And I will just mention that we have built and commissioned a Sunburst system at what we term our commercial scale. So in the EU, there's a grant program called Sweetwoods, where we recently commissioned at 80 dry metric tons per day, of throughput. So we're pretty excited about that. So we can make these materials, what can you do with them? That's really the big question, right? So just a real quick use case study. We partnered with a group that was looking to include our specialty cellulose into a mortar and cement application. And found that a very small amount of NFC, nanofibrillated cellulose, added into a mortar mix, actually it applied for our MCC as well, was able to increase double tensile strength while still increasing the bending and compressive strength. So 0.1/10 of 1% addition into a material of our bio-based cellulose can really improve things that we use every day. And that's what we're looking to do. And that's just one case of many. And I guess that brings us to why we're here. I'm running out of time, but we really focus on making these materials as efficiently and reliably as possible. We're looking for partners to take those materials and put them into your end products and into your processes. So I've listed a few areas here that we've looked at with ourselves or with partners and highlighted some that are more applicable to this conference. But if anyone listening has any interest whatsoever in these materials and think there might be some overlap, we love to have conversations, and I'll be in the lunchroom. So thank you for your time.
Excellent, and Scott will be next door if you have further questions for him. Moving right along, this one I'm especially intrigued about. We have Ross Bonner here, who's the CTO of Transera. He's also an MIT alum, engineer.
That's right. It's great to be back.
Developing a new class of affordable, energy-efficient, sustainable cooling systems to address the issue of air conditioning. We all know, and I'm sure you're going to share it, that tremendous environmental impact, but increasingly important as temperatures rise. And with that, I'll turn it over to you. Thanks.
Great. So my name's Ross Bonner. I'm CTO at Transera. It's good to speak with you today, and I realize that I'm the thing standing between you and lunch, so I'll try to keep it short. So why air conditioning? Transera is trying to make air conditioning more efficient and more affordable for everyone. Currently, air conditioners are a huge chunk of global greenhouse emissions. That number today is 4%, and it's growing fast. To put that in perspective, that's about twice the size of aviation globally. And there are about 2 billion with a B air conditioners in use today. That's about the same as the total number of iPhones that have been ever produced since the phone was introduced in 2007. So it's a huge number, and as I mentioned, it's growing really quickly. That 2 billion is expected to triple by 2050. If we meet this energy demand with today's inefficient technology, it will be a disaster for the electricity grid as well as the climate. So what's so bad about today's AC? It turns out AC has an Achilles heel, a big weakness, and that is water management. Your air conditioner is doing two functions. It's cooling the air, but it's also pulling moisture out of the air in the form of liquid water. That's how it's done today. And that creates some practical issues. The water can leak out, cause water damage. It can stagnate and grow mold. But there's also an energy penalty associated with pulling moisture into liquid form. And it turns out that actually accounts for about 50% of the energy use of today's air conditioners. So there's got to be a better way to do this. And Transera has found a way to remove moisture from the air, to dehumidify it, without ever condensing moisture into liquid water. We use these incredible new materials called metal organic frameworks, or MOFs, with nanoscale pores and extremely high surface areas. To give you a sense, about 2 grams of MOF, which fits in like a small vial that I could hold between my fingers, is the equivalent of about 1 football field worth of surface area. So that property allows us to pull moisture down onto the surface and hold it there, which unlocks some really incredible energy savings when we put it into a device. So I'll get into how it actually works. If we take a look under the hood of our device, any air conditioner or heat pump basically has 2 heat exchangers. One of them gets cold, one of them gets hot. And we apply an ultra-thin coating of our MOF material onto those heat exchangers and use them to dry out the air instead of pulling it into liquid water. So if you look here, do I have a laser? Yeah. So we also configure the device in a way so that we can switch which side is producing the cooling and delivering it to your room. So here we show the left side is cooling and water from the air is being trapped in the MOF on the surface of this heat exchanger. That goes on for some time, and then eventually it saturates. It can't hold any more moisture. So at that point, we switch, and what was the cold heat exchanger becomes the hot one. That dries out the MOF. It's then taken out into a hose, which hooks up to your window like any portable AC today, and goes outside. And what was the hot heat exchanger on the other side becomes cold, and then that cycle just repeats. And again, this allows us to demonstrate some really impressive energy savings over today's AC. It also gets us away from that problem of liquid water condensate, which I mentioned. So we're looking for partnerships in the form of manufacturing to help us scale up. So white goods OEMs, chemical manufacturers to help us scale them off production, as well as building developers and utilities to offer incentive programs and pilot programs to get the drive user adoption. So if that sounds like you, or you have any interest in our technology and learning more about it, find me in the next session. I'd be happy to talk to you.
Thank you, Ross. Thanks, Ross. Next up is Ubiquity. Dr. Hunter McDaniel, who's the founder and CEO, is here with us, and Ubiquity focuses on copper, indium, and sulfide quantum dots. I don't even know where to start on that one, so I'm going to turn it over to you.
Thanks, and thanks to the organizers, Catarina and the ILP program, for the invitation to speak today. When I heard about this symposium, I was like, this is exactly what we do. We deploy quantum dots, nanocrystals, into the facades of buildings. Our purpose really is around decarbonizing the built environment by deploying those materials. So briefly about the company, I was a postdoc at Los Alamos National Laboratory after a PhD at University of Illinois. And we're also licensing, so we're licensing technology from Los Alamos, but also exclusively from MIT. We have a couple team members that are alumni, and we also have some IP from University of Washington. 26 full-time employees, about $2.5 million in revenue last year, and we've raised about $8 million previously. Our business model is around manufacturing a new composition of matter of quantum dots, and those enable new products. So we do spend a lot of our time downstream developing those into applications. But we don't want to have to build a new kind of manufacturing process. We want to drop into existing value chains. So we work hard to make the dots in a way that they can be received downstream. So we have two main markets. The first one, where our first products are related to controlled environment agriculture. The second one is very similar to what you heard earlier from Miles. So I'm going to spare you that story, but you can come by the booth and see some demos of our solar windows. And ask me questions about that later if you want to know more about our solar window stuff. So these are copper indium disulfide quantum dots. They avoid those toxic heavy metals that were present in previous generations of quantum dots, like cadmium and lead. They turn out to be a lot lower cost because the manufacturing process doesn't require hot injection. And we describe this as the first kind of quantum dot that can become ubiquitous, and hence that's the name of the company, where the name of the company comes from. Ubiquity is short for ubiquitous quantum dots. They're about 5 nanometers roughly in diameter. We can tune the color by changing the size. That's what makes quantum dots so useful. Then we deploy those into substrates like plastic films that we can deploy into the built environment. So the main problem that we're solving that addresses both of these markets is around the energy and efficiency of buildings. They're responsible for about 40% of CO2 emissions on the planet. So specifically in controlled environment agriculture, if you want to optimize your light in a greenhouse, the only option you really have is to install lighting. It's very expensive, very energy intensive. And our solution is to take sunlight and tweak it to make it better. Take those underutilized portions of the spectrum and shift them over through fluorescence to the parts of the spectrum where photosynthesis is the most efficient. And instead of powering lights that just add those photons in the part of the spectrum that you want. There's a lot of science to back up that this should work. The McCree curve is shown here on the left. This is basically telling you the photosynthetic efficiency versus color of light. And red is the most potent, about 50% more efficient than green, about 30% more efficient than blue. And then outside of this range of about 400 to 700 nanometers, it's widely believed that the light's not really useful at all, although there's some caveats to that story. And then on the right is a chart just showing you that the highest value crops like tomatoes, strawberries, cannabis need very high light levels, daily light integrals, for them to grow efficiently. Lettuce would be one where you could get away with shading the crop, but if you want to go after these high value markets, you're going to have to not compromise the quantity of light, and that's what our product is designed to do. It's shifting over the parts of the spectrum and adding photons in where they're most potent, but without perturbing the light in that part of the spectrum in the red where the photons are most useful. So we have a product brand called UbiGrow. You can look that up online, ubigrow.com. It's been described as a first-of-its-kind product. Comes in rolls about 4 foot wide of arbitrary length. We can make kilometers per day with our current manufacturing process. It's roll-to-roll, and at MSRP is at about $3 a square foot. It's all about boosting crop yield, and we target markets where the payback time is less than 1 year. That means going after those farms where their economics and the crops that they're growing are such that we can actually boost their profits and pay for the product in less than 1 year. We do have customers that are using it with slower payback times and working to get our costs down so that we can address more of the market. In some cases, it's about faster cycle time. Some cases, you can bring value around improved crop quality. For example, in tomatoes, boosting the sugar content, or in cannabis, boosting the terpenes. Depending on the type of crop that you're growing, there may be some other benefits that Spectrum can bring. And again, this is a net zero solution. There's no electricity. Just to give one example of a happy customer, this is a farm in California where they're growing cannabis. They covered half the greenhouse with our product and did 2 trials with hundreds of plants and saw an 11% yield improvement. That's the final dry trimmed product that goes to market. And the payback time is about 2 months at that yield improvement, and the owner was quite happy with that. And you can see in the picture that the plants on the left are a bit bigger and bushier, so just you can actually see by eye in some cases. But we've done trials on, we are plant agnostic, we're not focused on cannabis. We've done trials on many different crops. You can see some of the results here, between 5 and 30% in commercial settings. And there's a huge area of acreage of greenhouses that we can serve by following through to the sales. I think I already talked about the business model. This is true for both windows and films that we're leveraging existing value chains. The product pipeline goes from retrofit products to fully integrated facade products, and from UV cured resins to extruded resins. Big markets, probably not hard to convince you of that, about 54 billion square feet of greenhouses on the planet. Miles did a great job of convincing you that there's a huge market opportunity in glass. Here's the team. I'm out of time, so I'm just gonna skip to the ask. We are hiring. We're looking for value chain partners. If you wanna just kind of follow us online, we've got these 2 social media handles, and specifically looking for industrialization, extrusion expertise, and technology integration. So that's it. Thank you.
Great job, Hunter. Thank you. Okay, so biomass, air conditioning, and now I know what quantum dots are. And now we're going to move on to RRTC. Dr. Richard Ryman is here. He's the founder. He's also an MIT alum from Material Science and Engineering. He's going to tell us about their work with composite materials.
Hi there, I'm Rick Ryman. Actually, just a little bit of trivia. I was actually in Building 12 before they leveled it and built that beautiful Build.nano building. So, big improvement, let me tell you. So just a little bit about me. I founded a company previously called Solidia Technologies. It's the world's only cement and concrete company that makes a green, low carbon footprint cement that hardens with CO2 instead of water. Just go on to the next thing, which is you've heard lots and lots today about materials and how they can really define an era. I believe we're in the era of advanced composite materials. And what I'd like to talk about is this process that I've invented in my lab at Rutgers called low temperature solidification. It allows you to co-process polymers and ceramics together. And yes, we can form ceramic bonds at lower temperatures than it takes to make a polymer, which allows you to co-process the materials together. Better yet, I use CO2 to cause the ceramic bonds, and it's a non-shrinking process, which is a really big innovation in powder materials processing. Materials are stress-free, crack-resistant, stiff, tough, flame-retardant, and strong, and they're ultra cheap. So what I wanted to talk about today is replacing wood. A lot of people will talk about wood being a carbon-negative material. I have a big disagreement with that. I think we should leave trees in the forest, and we should leave the forest floor, both for collecting CO2 and taking carbon out of the air. And we have much better ways of making materials that can replace wood. So I won't talk about all the other composites that this technology allows, but in replacing wood at least, we're talking about materials with better compressive and tensile strength. They're stiffer. You can't burn them, not even with a flame, a welding torch. They're infestation proof, and better yet, they're not biodegradable, which means they're not going to emit methane after you landfill them. So here's just a few examples of things we did where we just made a ceramic composite with high density polyethylene. Don't have time to go through the numbers, but it's going to tell you that we made it better than the polymer and better than the ceramic. Here's probably the most interesting one, is that even when we have a small amount of ceramic in the system, the material can actually be heated above the melt temperature of the plastic and still function. And we've done it with a lot of different polymers, so any kind of new polymers people have, we're real interested in seeing what you got. And here's a reason why you want to replace wood. So just looking at the pallet market, for example, there's 10 billion pallets in the world. They replace 25% of them a year. A lot of them go into landfill, emitting methane and CO2. And most of them only make one trip. So this is one of the areas we can get rapid adoption because there aren't any standards in this industry. Anything that's better, they're going to grab onto right away. And you can see a summary of the performance advantages in this case. We've worked with a lot of companies as well as government organizations. What are we looking for? Investors, upstream manufacturers of polymers, downstream technology licensees where we can drop our process in because we actually can manufacture very rapidly and very inexpensively. You saw earlier we could make materials at a cost easily of 50 cents a kilogram. I'm targeting 10 cents a kilogram to be possible. And if we do that, we'll be knocking all of the materials out that you might imagine that you might want to build with and be carbon negative at the same time, meaning we consume more CO2 in manufacturing these materials than we actually emit. Lots of different producers can benefit from these materials. I think we can make packaging materials from it, cardboard, paper, automotive parts for sure. I've got a lot of materials in my magic box over there. Here's an example of one. If this was a concrete floor, I'd show you how I could bounce this off the surface. And this material here costs less than 15 cents a kilogram. I'm done. Thank you.
Thank you, Richard. A lot more to talk about there, so we'll see you next door. And finally today, I'm delighted to introduce Dr. Noran Bayomi. She's a postdoctoral fellow at the MIT Environmental Solutions Initiative, also a double MIT threat, a PhD and a master's from the Building and Science and Technology Department. I'm also pleased to say she's an alum of our DesignX Accelerator program over at the School of Architecture and Planning. And she's here to tell us about Lamar AI, or Lamar.ai, which is an autonomous solution for rapid building diagnostics using aerial data. So with that, I'll turn it over to you. Thank you for being here.
Good afternoon. My name is Nurhan. I'm the co-founder and CEO at Lamar.ai, and we are a software company where we're developing an autonomous solution for building envelope diagnosis using aerial data and cloud computing. So we're living in an aging environment where every building being built add at least 50 years of carbon emission, energy consumption, and operation cost. And the US Department of Energy estimate that there would be around 10 million buildings that would be added to cities between 2016 and 2040 that would need to comply with the International Code Council. We also see the introduction of new building energy codes such as Build 2.0 and Local No 97 that would require a mandatory building envelope audit to comply with these energy standards. So why we talk about buildings specifically within the scope of our technology, we care about buildings, specifically aging buildings, where 50% of the building stock in the US were built before the year 1980, and also 40% of the US emissions is coming from the building sector. But more specifically, we are interested in reducing energy losses from building envelope that could constitute to about 40% of energy saving. So this requires a growing interest in improving building audit process, which is currently a very costly and time-intensive process that starts with hiring multiple auditors to do site visits and very time-intensive equipment that would require sometimes the occupants of the building to leave the buildings. and that to report findings to key stakeholders. And this entire process takes around 60% of the time just to do the data collection. That could be sometimes also inaccurate. So in Lamar, we developed a solution that used aerial data, IR and RGB data, and artificial intelligence to detect anomalies in the building envelope. So you can look at our technology as giving your building an MRI scan, where we're not detecting tumors, we're detecting building defects fully autonomously. So the core aspects of our patent technology is based on 3 key components: data collections from drones and computer vision models to detect anomalies, and finally, generation of 3D models that could be integrated into building energy modeling. So over the past 4 years, this is a spin-off technology from a research collaboration between MIT, Georgia Tech, and Syracuse that's funded by the Department of Energy. We have been developing the suitable flight path and data collection methods that are suitable for the building envelope audit. And the data that we collect from drones are directly processed using proprietary computer vision machine learning models that we have been developing over the years to detect building components such as doors and windows, but most importantly, building thermal anomalies. So any defects in building envelopes such as missing insulation or heat leakage, we detect this fully autonomously using our computer vision model. And then all these data that are processed from our algorithms are translated into a 3D model that carries the information of the anomaly location, the class of the anomaly, and directly integrated into 3D energy simulation models fully autonomously that current best practices are able to produce. So why our technology matters? Through the pilots we have been conducting over the years, we identified that our technology can cut down the time in building envelope audit by 60%. Most importantly, we're also much cheaper. So we are 85% cheaper compared to the traditional building envelope audit. And we are safer, more accurate, where we are eliminating the human aspect of data collection by replacing that with drones. Currently, our key users are large property managers and individual homeowners, where they can directly upload their data set to our software, which I will show in the next slide, to get results in a matter of seconds. So we have trained this model over thousands of images that we collected ourselves, where users can upload their data set, get results instantly, and identify what kinds of repair are needed also. We have also done a large campus pilot with Georgia Tech, where we validated the performance of our algorithms and the results that we're getting with 20 building scientists also across MIT and Georgia Tech. And finally, our team has the right expertise to tackle this problem, where we have expertise from building technology, AI-based solution, urban analytics, and environmental solution. Finally, before I conclude, I just want to say why we named our company Lamar. It's a tribute to the actress and inventor Hedy Lamar and all other inventors who didn't gain prominence during their time, especially women. Finally, we're looking to partner with a large property management company, building retrofitting company, and building analytics to test and validate our technology. So if you're interested to learn more, we'll be in the next session. Thank you so much.
Great job, Norhan. Thank you very much. And thank you to all of the presenters today. They'll be next door. I think it's now time for us to go to lunch, and then we'll be back for a great program this afternoon. Thank you, everybody, for a great morning.